Hi, y'all. Welcome back. This is going to be the guided practice for section 12.2. So you'll just need to have this done already so that we can go over it quickly and make sure that you're on the right track. If you are not, then we can take the time to go back and we can do a workshop over it. Make sure if you're struggling with something that you go up to the board and request a workshop if you need help on something so that I know what you think that you need so we can get you on the right track. So for our dot plot, let's see, we have numbers that are like 7, 4, 7, 5, 4, 10, 11, 6, 7, and 4. So the highest number we need is 11. Let's see how many slashes they have in the number line that they gave us. So if we start with 0 here, I could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, we'll have enough. So I just want to make sure that everything is going to fit, and I'm going to skip these. 7, 8, 9, 10, 11, 12, 13, 14, 15. So see, I just numbered the first part to get us going, and then I skipped over the next part. So for our dot plot, all we need to do is plot the points that are going to be on our graph. So 7, so we have a dot at 7. We have a dot at 4. Another dot at 7, a dot at 5, a dot at 4, a dot at 10, a dot at 11, a dot at 6, another at 7, and another at 4. So this is what our dot plot should end up looking like. So now we're going to make a box plot of the exact same sample. Now what's nice about having the dot plot first is that we can use it to help us make this. We can see what is our lowest number, what is our highest number, to see where we need to put our dots at. Our lowest is going to be 4, so once again, looks like they're the same size. So we're going to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Perfect. So our lowest number is going to be 4, so I know I'm going to at least have a dot here. Our highest number is going to be 11, so I'm going to have another dot here. So that's my minimum and my maximum values. Now I do have to go back and put my numbers in order. So once again, our dot plot's going to help us. We're going to use it to make our list in order from least to greatest. So we have 4, 4, 4, 5, 6, 7, 7, 7, 10, 11. So now I can find my medians. Remember, our medians are our middle numbers. So how many numbers do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 10 numbers, which means I'm going to have 2 middle numbers. So we have 4, 11, 4, 10, 4, 7, 5, 6, 6, 7. Uh-oh, did I mess up on that? Let's see here. 4, 11, 4, 10, 4, 7, 5, 7, 6, 7. Okay, I did. I knew I missed a slash somewhere. So our middle two numbers are going to be 6 and 7. We need what is exactly in the middle of those. It is going to be 6.5. So we're going to come over here. We have 5, 6, and 1/2. So I'm going to put a dot there. Then I'm going to go over it and make a line. That's going to be my median. So now I need all the numbers to the left and all the numbers to the right so that I can make my upper and lower quartiles. So numbers to the left, I'm going to have a median at, let's see, 4, 5, the numbers in between 4 and 4, well, nicely, that's just 4. So look, this is something different. We have our lower value, our lowest value, and our lower quartile are the same number. That's interesting. And now for the next one, let's see, we have 7, 11. Now, here's a little more confusing one. The number that is directly between 10 and 7. If you're not sure, average it out. We have add them together. So 10 plus 7 is 17. And divide by 2. So 2 goes into 17 8 times. So we add a decimal and bring it down a 0. And it ends up being 8.5. So we're going to go 5, 6, 7, 8.5. and up. And let's see here. Did we make an error somewhere? No, I think we're good. So, remember we just connect our boxes. Alright, so number 3 says the most common age of children that use the library is 4 and 7, because we have the same amount for each one. The ranges of the age of children that use the library is from 4 to 11. So we go all the way from 4 up to 11. That's our range in ages. Our median age of children that uses the library is 6.5. That's the one that we found right here. Oh, and I forgot to connect my whisker. So, a manufacturer fills an order for 4,200 smartphones. The quality inspector selects a random sample of 60 phones and finds that 4 are defective. How many smartphones in the order are likely to be defective? Refer to example 1 if you weren't able to do this, but the way that I did it was I set up a proportion. 4 out of 60 are defective. So how many would be defective out of 4,200? Solve out your proportion and you end up getting 280. Number 7, similar problem, just different numbers. It says part of the population of 4,500 elk at a wildlife preserve is infected with a parasite. A random sample of 50 elk show that 8 of them are infected. So we know that 8 out of 50 are infected. So how many would be infected out of 4,500? Set up your proportion and solve it, and when you do, you should get 720 elk. So it says, how can you use a random sample of a population to make predictions? You can set up proportions, which is what we just did, using the information obtained in a random sample of the population. That's exactly what we did on these two numbers, on these two problems, 6 and 7. For instance, the number of defective parts in a batch can be used to predict how many parts will be defective in a different size batch. So if we found a different size batch, say they ordered 5,000 next time, or they ordered 10,000 next time, you could use that information in order to help you figure out about how many you would have defective. So hopefully this was helpful. If not, please do request a workshop and we can get you the help that you need. Okay, enjoy. See you next time.